In this video, we are going to go ahead and cover user awareness and some small performance enhancements that might help out. So one of the things we did earlier in our project settings, I open this one up every time, in our project settings under rendering, was to enable instance stereo. Well, there's a few other things we might want to do in order to help our performance. They generally have to do with things like post-processing that is really not very helpful on a VR device. Now, let me go ahead and pull up the frames per second. Let's go ahead and run this. And if I pull up stat FPS, we're going to go ahead and see on this machine we're at about a constant 90 frames per second. Now, what we want to use is the profile GPU command. So if I go ahead and run this again, and I pull up my console, and I type in profile GPU, it's going to go ahead and take a snapshot basically of the frame I was currently at, and then pull it up on the GPU virtualizer. And you can see this right here. Now what you can see here is basically what is taking up the majority of our GPU. And you want to look for your larger numbers. So like in here, well, we have a 0.79 on our base pass. And that's going to be drawing all of our static issues, static things. If we have this large number here for view 0 though, lighting composition, darn it. Lighting composition, try it again, view 0, lighting composition tasks. And then you can see ambient occlusion is taking up a huge amount, 3 milliseconds itself. Ambient occlusion is pretty much taking up this entire 5 seconds. That's a huge issue. We also have another one down here under post-processing. And if we can find it, we have some things like the tone mapper, weighted samples, temporal AA is causing an issue. There's another one in here for RSAA. Oh gosh darn it, I forget it every single time. But it is the, here we go, SSR, that's what it was. The screen space reflections is another one that takes up a good chunk. And we're going to cover how to fix that. So if we go back to our project settings after doing the profiling, some of the things you might want to shut off down here under our post-processing are bloom, ambient occlusion for backlighting. I personally don't like the auto exposure, so for this example I'm shutting it off, and then motion blur. If we go ahead and close this out, save and hit play, this time we'll do another profile GPU. We'll see what it has to say. And we'll notice we went from 11 milliseconds down to 3.8 milliseconds. A huge difference. Now we still have a couple things in here, such as post-processing is still having an issue here. Our temporal AA is taking up 0.49. We could always change that over to FXAA or no AA, and it would reduce it even further, but it will give you a little bit of visual cost. And then you have also in here, the one that I lose every single time I'm looking for it, screen space reflections. Now, screen space reflections, we can actually shut off completely. Using a post-processing volume, if we go ahead and just drag one of these into the scene, you can actually find all your settings for the things we couldn't change inside of our rendering. Now if we go in here for the screen space reflection, we can actually change the intensity down to 0, and this is going to turn off screen space reflections. We're not using them, so there's no point in them taking up resources. One issue here, unless you want to cover your entire level with the box, if you click unbound, this will now apply these settings to everything in the scene. So now if we go ahead and play again, profile GPU, we'll go ahead and shut this down. Well, now we're down to 3.2 milliseconds. I didn't say seconds that time. And you can still further down and figure things out that might be causing more. We still have post-processing. This gosh darn it. Temporal AA is still taking half. Maybe we want to shut off temporal AA. Let's see, it's under miscellaneous, AA. We can set that to none. We can run this again. Profile GPU. Shut it off. Oh, look, we're down to 2.2 milliseconds now. Our post-processing is down here to half by itself. And you notice we no longer have the temporal causing an issue in here. We just have some things like our bokeh and our tone mappers. So all of these settings, for the most part, it's your post-processing that's going to give you your biggest impact. And a lot of them you don't really need, especially in VR if you're trying to hit your 90 frames per second rate. So I went ahead and I'm going to keep that like that. You can obviously adjust it as needed. I think I might go in my AA and turn on FXAA. We'll see how that affects it. See, that's a nice thing. You can just run your scene, profile the GPU, see how much of a difference it is. We'll go into our post-processing. It looks like it's going to give us a little bit more for our post-processing. AA, 0.16. So it's a combination between the temporal and the none. So it might give us a little bit of a quality difference. So now that we've made it perform a little bit better, when we're playing our game and we start, there's no indication we're starting. We can't even tell we're hitting our buttons, for example, let alone when the new waves are going to start. And that's something we kind of want to make better. Let me start that back up again. If I was to turn around, for example, or even look left or right, I wouldn't be able to tell when levels are starting. I wouldn't even be able to tell my score or any of that stuff. And we want to fix that. You don't have a fixed UI on a VR for the most of the time. It's more of a heads up or interactive. So we're going to go and adjust that. First thing we're going to do is we're going to make it where the buttons give us feedback when we're shooting them. Traditionally, you'd have a clicking action when you are using a mouse. We're just going to give it a color change. So let's go into our UI. We're going to want to go into our actual widget for our game menu. And we're going to want to set up a few different events. What we're going to do is basically just change the color for a second before it starts. Let's rename our buttons to make them easier. Button start and button quit. Save and compile. Let's pull our button start on clicked event and our button quit on clicked event. And I don't know why I did the on clicked. Let's make new events. Custom event. Button start. Let's call it toggle button start. Custom event, toggle button quit. And now we have two events we're going to use. One of these when we start, and one of these when we hit the start button, one of these when we hit the quit button. And this is pretty simple. Let's get our button start. Let's get the background color, and we're going to set the background color. And since we've been using green as an indicator of good, we'll set it to green. We'll do a delay of 1.5 seconds. Now I did say we were going to go ahead and change it for 1 second. So why are we doing 1.5? Well, there's a reason why. We need to change it back to white after our time here. So we'll change it to white. And it's set to 1.5 seconds so that way you don't really see flashing. When we hide our widget, let's go to our widget blueprint here, and we do our start game. So we need to pull up our VR mode, our framework, and we do these things, our hidden game and collision. Keep in mind it's just hiding it. The widget's still there, so if there's any tick events, they'd still tick, or if there's anything still running, they're still going to run. So what we're going to end up doing is changing the color, waiting 1 second, and then spawning our enemy wave, and then hiding and spawning our wave. After 1.5 seconds, we're going to go ahead and switch it back to white, so that way the next time we start up our menu, it'll be back to our white color. Hopefully that makes sense. Let's go ahead and just cheat and copy these ones, because we're going to do the same thing, except this time it's going to be the button quit for both of these. So now whenever we call these events, we're either going to toggle the color for the quit or the start button. And that's all we're going to need to do inside the widget itself. Let's go and close down our widget. And we need to go ahead and actually toggle these things inside of our controller. And our controller is, of course, our blueprint. So in here, basically we're either quitting or we're starting. We're doing one of the two. What we want to do is actually toggle the button before we do this. We'll move this one over because it's easiest to move. Hold down the right mouse button and just slap a bunch of space. We will take our widget, which is our widget right here. We're going to get the user widget. This is going to give us a reference to the actual widget we created, our main menu. We're going to go ahead and cast this to the appropriate in-game menu widget. You may remember we did this when we were working on our player score. I went ahead and converted to a pure node so I don't have to execute it. And then we're going to go ahead and do the events we set up, which is toggle button start. Wire this in. Make this a little more funny. And there we go. So now, if we were to shoot our start button, hopefully this works. It'll go green for a second, and then it'll start. And of course, it did not. And why is that? Well, I said it'll go green for a second, but I kind of never actually set that up. So let's go ahead and set a delay for 1 second. So that way it actually waits 1 second before it starts the game. Try that again. Start the game, and boom, there we go. So it gives us a little bit of a visual feedback. Our user's aware that they've actually clicked on that rather than wondering what's happening. Plus, it kind of gives them a little bit of an indicator that something will happen. So, we should hopefully be able to figure out what to do next. We'll go ahead and just simply copy this over for the quit game. Slap this sucker right here. We're going to go ahead and toggle quit. Put this in our true right here. We need to delay. So let's add a delay for 1 second. We're not going to test this right now because we will be testing these things shortly anyways. So right there, we've gone ahead and our quit and our start now have a visual feedback. So we're halfway there. Now we need another way to give some more visual feedback. Now there's a couple different ways. Originally I had it set up where the player score would flash, but that would require you to watch the player score at all times. Something I thought would be more interesting and more fun for learning something else is making the actual floor and the ceiling flash. Now I say the floor and the ceiling because what we're going to do is we're going to make the material flash. And when the material flashes, since we have the same for the floor and the ceiling are going to flash. So let's go ahead and implement that. So what we want to do is we're going to use material parameter collections. I know it sounds like a lot, but basically it's a way of changing a variable inside materials, a parameter, without actually changing the material itself or having access to the material or even having a dynamic material in the case of a blueprint. So put that into words. Let's go ahead and do that. We're going to go to materials, material parameter collection, and we're going to name this our floor mat MPC. Floor material parameter collection. Probably don't need all those M's. Let's just name it the floor MPC. There we go. So when we pull up our floor MPC, we're going to go ahead and we're going to find our asset here. And basically it's set up with nothing in it. We want to create a vector. A vector is going to hold our color. And we're going to name it grid color. Because what we're going to do is change the color of our grid. And that's pretty much it. Let me change my default value to 1. With 1 for the alpha, so it's 1, 1, 1, 1, just so that way when we use this, we're going to get white. Now that we have our material collection, we need to actually modify our material to use it. This one's pretty simple. We are going to basically take this color here, multiply it, so let's put a multiply node here, by another color from our material collection, and then put it into our emissive. Because we have a black and white image, our black is basically going to stay black, and our whites are going to become tinted by whatever color we have set up. So what we need to do is we need to find our material parameter itself. So once this is done saving and being a giant pain in my butt, we need the material parameter collection itself. So if we type in material, and we look around, we are going to not find what we want. Let's do collection. There we go. We're looking for collection parameter. Don't know why they didn't just material collection. Correct. Material collection parameter. It's collection parameter. It's got two things we set up. One, select the collection. So we're going to do our only collection. Two, which parameter? Grid color. That's it. Super simple. Now if we plug it in over here into our multiply, we're going to run into an issue. We'll go ahead and save this, and we'll see what the error is. The error is this is outputting a RGB. This is outputting an RGBA, because if we noticed in our collection itself, we had 4 values. So we have a float 4, a vector 4 technically, against a vector 3. This is super simple to fix. We have a component mask. Basically, a component mask takes in values and then gives us back whatever we want. We change this into an RGB and apply. Now we're taking the RGBA, turning it into RGB, and multiplying it right here. So again, once this finishes saving and such, our default color is white, and it's multiplying against white, so we should see no change at all in our scene, and we don't. We still have everything set up exactly like we want it. Now we are going to run into an issue, and I'll cover that shortly, but for now, we're good. We're going to want to now change that grid color parameter collection. Now, where would be the appropriate place to change that? Well, our VR mode is the one that sets up the plane, starting in the plane and things like that. So if we're going to go ahead and flash something, it should be in our VR mode. Now, it's meant to indicate when something's happening, when we're spawning. So do we have anything already set up for that? Well, let's not open the enemy spawner. Look at our VR game mode. Do we have some way of knowing when we're going to spawn a new wave? Well, we do. We have a spawn enemy wave. And we have the spawn enemy wave calling itself. Now, here's a problem we're going to run into. I want to animate a parameter. I want to animate a parameter between 0 and 1. Now, there's a couple ways of doing that. Well, actually, a couple parameters. I want to animate the red and the blue from 0 to 1 and keep the green at 1. So that way it looks like it's flashing green. The problem we're going to have is in order to do that easily, you need to kind of do it on a tick or delay or traditionally a timeline. And those cannot work inside of functions. If we were going to do a timeline, no, well, and I spelled it right, it won't work. If I was going to do a delay, it's not going to work. So we need to do it outside of here. So what we're going to do is basically keep the spawn enemy wave. Its only job is to spawn enemy waves. And we're going to have another event out here whose job is to spawn the new waves, to do the entire thing. So flashing a score or flashing the grid or playing a sound like new wave incoming. It's an event that's going to handle spawning the new wave. So let's do a custom event. We'll do handle spawning new wave. This event handles spawning the new wave, everything associated with it. So if we were to just go here and do spawn new wave, which of course it's spawn enemy wave, and we did this, anytime we called handle spawning new wave, it'll spawn an enemy wave without an issue. So we're good there. We need to unfortunately go back to our normal spawn enemy wave and adjust this, because this is going to call itself, which is not what we want. We want to make sure this calls the handling event so that way it handles everything. I know it seems a little confusing, but we'll go over that in a second. So I'm going to copy that name out, paste it in here just so I can make sure it's done properly. Now if we were to rerun this, and I was to turn my controller back on again. I think I turned the wrong one on last time. Yeah, that's what happened. The wrong one turned on. When we start the game, you'll notice it's going to run normally. Game runs, things fly out of the screen, and it will continue like this, and it will handle properly. No difference. That's exactly what we want. Now, if we decide in the future we want something to happen, like our flashing, it goes in our handle spawning new wave section, so that way it doesn't interrupt actually spawning the enemy wave. All this does is spawn. This handles plain sound effect, plain particles, flashing colors, and then spawning the enemy wave. So let's set that up. The nice thing is this should be pretty simple. We're going to do a timeline. We're going to actually click and do a timeline. We're going to click and do a timeline and add timeline. Let's, for the sake of simplicity, name the timeline, and we'll call it color change. Why not? We'll call it color change. What we're going to do in here is set up a curve for a color, and we're going to drive the color of that material parameter collection. I know that was a lot of colors there, but this is what we're going to do. So we're going to create a new color track. These are pretty simple. Let's make sure our length is 4, because we want a 4-second track. Now down here we have click this area to add color stops, and if I do, you'll see color stops. And then we also have click this area to add opacity, and if I click, you'll see opacity. And if I click in the middle here, or right click and add key, you'll see a top and a bottom. You'll see it add in a alpha, and you'll see it add in a color. We just want color. We're going to create 4 of them, one every second. Let's zoom out a little bit. Hold the right mouse button to scrub. And I'm just going to roughly hit 1 every second. Assuming it'll let me. There we go. And then if we click on 1, we can change it. We'll change the time to 0. Choose the color. It starts off at white, so we're good there. Click on the next one. 1 second. Choose the color. Let's make this one green. Next one. 2 seconds. It's already white, so we're good. Next one. Choose the color. We'll go to green this time. And keep in mind, this is personal preference. Change it to color you want. Make sure we change the time to 3 seconds. And not a bracket. Last one, 4 seconds. And then we're done. This is going to go from white, green, white, green, white. We're going to get a fluctuated output. And what we want to do here is where it says new track 0. Let's rename this to new color. We can close our timeline, and we now have a timeline that when we run it is going to output a new color based on this bar. Now, let's unhook this from play and hook it into play from start, because we're going to find if we call this again and we do play, it's just going to not work properly. We want it to play from the start. Next thing we want to do is, well, what are we doing with this color? Now that we have got it, what are we going to do with it? This is super hard. We're going to set the vector parameter value. What are we going to set it to? Well, the new color, which I dragged off. And then what collection? Well, we only have one collection. What parameter name? Well, we only have one parameter name. And actually, I lied about it being super hard. That's it. That's all we have to do to change the color. Now, after it does the color change, after this runs through, it's going to go ahead and spawn the enemy wave. Now, obviously, we might want to wait for this to finish before we spawn the enemy wave. So let's go ahead and plug in finished here. And go like that. We'll go ahead and run this. Once again, try to hit start game. There we go. And it did not work properly. Now, why did it not work properly? Let's see if it goes through the next wave. Actually, you notice it kind of like quickly jumped waves. So what is our problem here? So handling spawning new wave should run through this timeline, update the color on this parameter, and then after that amount of time, spawn a new wave. Every time we handle spawning a new wave, it should play from the start. Well, an issue is when we're changing a parameter back here in our materials. You cannot change the parameter on a master material. If you look at this material and you look at it, it just says material. It's a master. It is not allowed to have its parameters changed. What we need to do is create a material instance, not duplicate. Create material instance. And it will say it's a material instance. Now if we were to open up the material instance and look at it, you're going to find that it has some settings we can change. If we were to now take this material instance and drop it on the ceiling and the floor, like that. So now we have the instance selected on the top and the bottom. And we hit play again. Let's try this again. And we hit start. It should be working. And of course, it's not because it's being a giant pain in the butt. So we'll go back and we'll see what is going wrong here. Have we actually hooked up our events, which is, yep, nope, look, did it again. See? Start game, reset score, setting, and we're spawning the enemy wave again. Once again, I did not handle spawning the new wave. I didn't hook everything back up. So you always try to walk through it and talk through it. Now we'll handle spawning the new wave, which should handle our color change. And let's hope it works. Let's see. There we go. Now you notice the floors change, and then the enemies spawn. Now, of course, there were some off screen, so we couldn't see them. Let's see. You know, after the wave ends, it should flash again to signify the next wave starting. Fortunately, it's not, and we seem to have a problem here. So what is our issue? If we go, obviously it's got something to do with our spawning, because that's what we changed. And we kind of made a seriously small issue here. Hopefully you didn't have this happen, but this is a good way of double checking if we think things through. Basically, this gets called, and we notice the colors are changing, and we notice it's spawning. But the problem is after they're done spawning, it's not spawning the next wave. And why is that? Well, I accidentally typed in handle game over instead of handle spawn wave. That's a small issue. So let's copy and paste the correct one and try this again. Fire. Starting game. Nice indication. So the nice thing about that is I can be looking anywhere. So like, let's look over here. Ooh, I cannot aim that like that. Once everything's done spawning, no matter where I'm looking at, I'm going to get a visual representation of the next wave spawning. And then, boom, next wave spawns. When it ends, it's going to go ahead and it's going to let me know it ends by doing the same thing. Because we handle it spawning, and then once we can't spawn the next one, we go ahead and stop it. And then that's it. Now if I was to quit the game, it would work fine. If I was to start again, it would work fine. One nice thing, since we've kind of moved things around a little bit, this section right here, whether or not we want this to actually do anything. This is in the part where we spawn the enemy wave. It would probably be smarter to pull this out like this and move it into our event graph for handling the spawning of the new wave. Because we don't want to check this information if we're already told the game we should spawn. Spawn enemy wave should literally do nothing but spawn the enemy wave. So now that I've moved it over here and we play again, we should get the same results. But the difference being once the last wave is done, instead of us getting another indicator and then game over, it should go straight to game over. So we'll wait for this to finish. I'm going to go ahead and shut off my FPS while I'm here. We'll get our second wave. There we go. There's our green indicator. Second wave fires off. It should finish up. And then it should be game over. Now, there is something small that I don't think anyone has noticed. And if you have noticed it, then kudos to you. I did mention something about how the enemies were going to react, but we kind of never implemented it. And you really don't notice it because when you're working in VR, it's kind of hard to come back in here and notice some things. So if we were to play this, and let me go back into the editor itself. Oh, I got to start it. Let me start it and then go back in the editor. Let me click on the editor, click on firing, starting the game. We'll go back into our editor here. And let's watch here. So here's our enemies, right? Our enemies are flying through the scene, and they're nice and happy. At some point, they're supposed to get destroyed, and then more enemies will spawn. Now, the issue we're going to run into here is, well, they don't. More enemies spawn, but our original ones don't get destroyed. Remember, we're not using collision. We're not using any sort of way for them to stop. Because we're not using collision or any way for them to stop, they will continue indefinitely, and they will take up memory, and take up space, computation, and eventually your game will slow down. It's a really easy fix. One reason also why we're not using collision and triggers and volumes and overlaps is the least amount of physics you have to worry about, the better the performance you'll get. And that's important with VR. So we're kind of doing the easy way. We know once it's outside of the grid, or after a certain amount of time, we can go ahead and get rid of it. Let's go into our enemy. And every actor has an initial lifespan. This is great. You don't have to code anything like after X seconds, kill it. You just type it in here. So we'll type in something like 13. Now we'll go ahead and run this again. We'll tab back into the editor itself, and we'll watch our enemy spawn. Now, keep in mind our cooldown is 10 seconds. So we're going to see more enemies spawn, and then we'll see our original enemies disappear. So we'll wait for that. We should get a couple more enemies spawning. Oh, deleted, and more enemies. Actually, I guess I was off by the amount of time. Maybe I did 15 seconds for the interval. But as you saw there, we went ahead and deleted. We'll wait that time again, 13 seconds. These enemies will get deleted. And then there we go. And now technically the game's over if we were to go back into it. And we could quit. Something to keep in mind, especially geared towards mobile or VR. Maybe you want to use a pooling table or something like that. Actually, I'll cover that in the conclusion. This is going to end this video. In this video, we went ahead and we wrapped up a little bit. We made the user more aware of what's going on by making our buttons physically give visual feedback. We made the floor and the ceiling give us visual feedback by using a material parameter collection. And we basically gave the game a little bit more of a feeling that the game and the player are in sync and the player knows what's going on. The next video is going to be our conclusion. I'm just going to wrap everything up, cover at a high overview of what we've done, and then maybe throw some ideas in there for some things that could be worked on in the future.